In this tutorial, we will examine several methods of preparing a histogram in Excel. A histogram is used to show the frequency distribution of the observations in a data set. For the purposes of this tutorial, I have collected 10 years of daily data on the S&P 500 index. In column G, I've calculated the return for each day. Our task is to prepare a frequency distribution or histogram for the returns on the S&P 500 index. Our task will be much simpler if we assign a range name to the return data first. I'll start by placing the mouse on the first observation here in cell G2, and then using Control-Shift-Down arrow, I can highlight the entire data set. Then I'll go into the Name Manager and add a new range. Excel sees the word return in cell G1 at the top of the data set, and by default will assign that name to our data. The first method we will examine is on the tab labeled Histogram 1. Here we're going to use the frequency function built into Excel to prepare our histogram. While it is not necessary, I've prepared a section at the top of the spreadsheet in order to calculate our bin width. The smallest number in our data set is minus 0.09. We need a number slightly below that for our first observation in the data set. I'll use minus 0.1. The largest observation in our data set is 0.1158. If we take the max minus the min and divide it by the number of bins that we would like to have, we can find out how wide our bins need to be. In this case, when we prepare the histogram, we'll have 20 vertical bars on our chart. Next, I'll use the fill series command in order to create the rest of the bins. Our first bin is at minus 0.1. I'll click on Home, Fill, and Series. Be sure to check the column as we want the numbers in column A. We'll step by 0.01 or 1%. I obtain this number here in cell B8. Our stop value needs to be just larger than the maximum number in our data set. The maximum is 0.115. Let's set the stop value to 0.12. Excel has now created the bins for us, going from just below the minimum of our data set to just above the maximum in our data set. The frequency formula must be entered as an array formula. We'll click here in cell B11, and then holding down the Shift key using the down arrow, I'll highlight the cells next to our bins. This is where Excel will count the number of observations in each bin. Next, we'll click up here in the formula bar and type equals frequency. It requires two parameters. The first is the data array. Fortunately, earlier I had named our range of data the word return, and so we can simply type in return. Next, we need to tell Excel where the bins are. The bins are here in column A. I'll highlight those and then type my right parentheses. Normally we would press Enter at this point, but not for an array formula. Instead, we must press Control-Shift-Enter, all three at the same time. When we do that, Excel enters the frequency function as an array. We can see it puts a curly bracket on the left side of the formula and another curly bracket on the right side of the formula. That tells us that these are array formulas rather than ordinary formulas. So now Excel has counted the number of returns that are less than 0.1. None in this case. There is one return between minus 0.09 and minus 0.1. To prepare our histogram, we'll simply highlight both the bins and the count. We'll click on Insert and Bar Chart. Don't choose the histogram, however. It will give you undesired results. Instead, we'll come down here and click on More Statistical and use a column chart. We want this chart right here, the right-hand one. And we're almost done. We have our histogram now. We have the returns on the horizontal axis and the number of days on which we observe those returns on the vertical axis. We should change our title to something meaningful. In this case, S&P 500 distribution of returns. We need an x-axis label also. We'll click on Add Chart Element, Axis Title, Primary Horizontal, and we'll type the word return in here. On the vertical axis, we'll add a chart element, title, primary vertical, and we'll type in count. We now have a nice distribution. Chart has a title at the top, a label on the x-axis, and a label on the y-axis. This concludes our tutorial on using the frequency function in order to create a histogram. Next, we'll use the built-in histogram tool built into Excel. We'll click here on the tab labeled Histogram 2. Up here, there's some notes for us to read. It says, if you don't enter bin numbers in the worksheet, the histogram tool automatically creates evenly distributed bin intervals using the minimum and maximum values in the input range as your starting and ending points. However, these bins may not be useful. We recommend using your own bin numbers. Let's see what happens when we do this. We'll click here on cell A3 and then go Data, Data Analysis, and click on Histogram, OK. Earlier, we named our data range return, so we don't even have to know where it is in the spreadsheet. We just type in return. We're going to leave the bin range blank this time. We'll click on Chart the Output. Let's put our output range right here in cell A3, and we'll chart the output. Click OK, and Excel will go to work for us. Here's the problem. Excel uses the lowest observation in our data set, and we get numbers with way too many decimal places out here, inconvenient bin upper and lower limits. However, the results are the same as we saw earlier. Same distribution we would see over here on this method using the frequency. We also see a similar chart here on the histogram. Notice, however, that the x-axis labels here are difficult to read and have way too many decimal points. We can try to change the number of decimal points. We'll see if Excel will allow us to do that. We'll go to Number, change it to Number with 2 decimal points. We'll see if Excel will let us do that. I don't think it's going to work here in this case. Nope, no luck. So that's the downside of using the data analysis histogram tool and letting Excel pick the bins. We get inconvenient formatting in the numbers, and we don't have any way to change them. This concludes using data analysis histogram to build our histogram using the default settings. Next, we'll look at a preferred method on the tab labeled Histogram 3. On the tab labeled Histogram 3, we will again use the built-in histogram tool from Excel. However, this time we're going to create our own bins in order to avoid the problem we saw here with inconvenient values for the upper bound on each bin. We'll look at our data set. We see the first observation, or the minimum observation, is minus 0.09, so we'll set our first one slightly less than that, say at minus 0.1. We'll use Home, Fill, Series, and click on Column. Our step value is how far apart we want these bins to be. We've calculated that if we want 20 bins, then they need to be about 0.01 apart, 1%. So we'll type in 0.01, and the stop value needs to be slightly larger than the maximum number in our data set. We'll type in 0.12. We now have bins available to use to count our data. Next, we'll click on Data, Data Analysis, and Histogram. For the input range, we can simply type return. We specified this earlier. The bin ranges are over here. We'll highlight those. Oops, a little too far on the bin range. Like that. 33. For the output range, we'll set our output right here. We're going to put it in the same row that the word bins appears here. Excel will recreate our bins in its output. And finally, we'll click on Chart the Output. When we click OK, Excel recreates the same bins that we did over here on the left and counts the number of observations in each one of those bins. It also creates a chart for us that looks very similar to our other charts. Notice the labels on the x-axis here are formatted nicely in contrast to the labels when we let Excel create the bins itself. We should go ahead and correct the labels on the x-axis and the title at the top of our chart. I'll leave that for you to do at your own leisure. Finally, we're going to use the pivot table tool built into Excel to create our histogram. You may recall that earlier I did not include the header, the word return, when I defined my name range. We don't need to do it, but it does make our job a little easier here. I'm going to go back to the S&P 500 tab, start in cell G1, do a Control-Shift-Down arrow, and define a name for our data set. I'll call it return 2 just to have a different name on it than our earlier range, which did not include the header at the top. We'll go back to our pivot table tab. We will insert pivot table and we'll type return 2 as the name of our data set. We only have one variable in that data set, and that's the returns. We'll drag it down here into the cell labeled row, or drag the same variable down here into sum of values. We don't want the sum of the returns. We want the count. So we'll click on Value Field Settings and switch over to Count. Now, we have one of each observation. We need to group our data here. Click on any cell in the pivot table itself, right-click, and we'll group. Same procedure here. We'll start at -0.1, and we'll go up to positive 0.12, and we'll group by 0.01. So now Excel has built a set of ranges very similar to the ones that we did earlier. The difference here is that Excel, when you group, shows a lower limit and an upper limit on each one of your ranges. Because of the way that Excel stores numbers internally, sometimes we get some decimal places out here that aren't really desirable. However, there's nothing we can do about them. Excel converts the numbers into text fields, and we can edit the text, but we'd have to be very careful. We could type in incorrect values that would affect our pivot table. So we're clicked inside of our pivot table here. We'll go up and click on Insert, and then over here in the charts is our pivot chart. We'll click on Pivot Chart. It defaults to the histogram bar chart that we want. And so we're done. There it is. Excel has created the distribution chart for us. It's chosen the number of bins here based on the input we got. Very similar to what we did over here on histogram number 1. There's histogram number 1, where we use the frequency function. And here's our pivot table showing us the same. This concludes our tutorial on using Excel to create histograms.